Hello, grade 10s. Today's lesson, or this week's lesson, is on function notation. I want to start with a bit of a review from last week, reminding you that domain is just all of the x values, and range is just all of the y values. Now, when you're finding the domain and the range, we have two types of relations, or you might think of them as two types of graphs. We have discrete graphs or relations where we have individual points on a grid. And then we have continuous. And continuous relations is where the points form a line on our grid. Okay. Now, for each of we're going to do a couple of examples. For each of the following relations, we want to state the domain. Remember, domain is x, and we want to state the range, which is y. Remember, I said the tail hangs down on the r and on the y to remind us which is which. And then we're just going to determine if it is a function or not. That's just a yes or no. Okay, remember, use your vertical line test for that. All right, for stating our domain, so our x's. So we'll start here. X goes left and right, so we've got a point there, 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 and there. So individual discrete points go in a bracket from lowest to highest. So we're looking at -1, 2, 3 for the first one, then -1, then 0, +1, +2, and +3. Okay. For our y's, we're going up and down, so we're going down 2, down 1, at 0, and up 1. So again, the discrete points go in a bracket from lowest to highest, so -2, -1, 0, and 1. Now, looking to see if this is a relation or not, we're just using our vertical line test. And when we go through all of these points, it does not cross more than one point with our vertical line test, so this is yes, a function. Okay, looking at the second graph here, remember that we have open ends on this, which means this is not included, but every point on the line in between those two is included. So this is a continuous graph. So for our domain, we're looking at x. The lowest value of x is down at -1, 2, 3. It is not equal to -3, so we're just going to say x is greater than that lowest value, -3. And again, it's going to go to the highest value, +1, 2, 3. And x is going to be less than that 3, but not equal to it. For our range, we're looking at going from the lowest value to the highest value. So our lowest value is down at -1, 2, 3. And again, it's not equal to, so this is for our y is going to be greater than that -3. And then our highest value goes up to +1, 2, 3, 4. And it is including that line, so it's going to be, x is going to be less than or equal to 4. That's the highest value. Now, using that vertical line test again, there's no point on there that would cross or get 2 points crossing on that line. So this is yes, a function. Looking at our third example here for our x values, we're looking at the lowest x value and the highest x value. So x is going to be greater than or equal to the lowest value, which is 1. And it's going to be less than or equal to the highest value, which is 1, 2, 3, 4, 5. Okay, for our y's, There's our highest value, there's our lowest value, so our y is going to be greater than or equal to the lowest value, which is 0, and less than or equal to the highest value, which is 1, 2, 3, 4. Is this a function? Well, simply using your vertical line test, you can see it's going to cross that vertical line more than once, so this one is a no. All right, moving on to the last graph, okay, thinking about the arrows on there, meaning that it is going to go on infinitely, so it's going to continue to go up, but it's also going to continue to go out, okay? And down, it's going to continue as well, so it's going to continue to go down, but it is in fact spreading out. So that means if it's going to continue to spread out in the left and the right direction, that our x's are going to encompass all of the real numbers. And same thing for our y's, it's going to continue to go down infinitely and continue to go up infinitely, so y is going to encompass all of the real numbers again. And if we use our vertical line test, it doesn't matter where we go here, we're not crossing that line more than once, so this is yes function. Okay, that's a review from last week. Now on to our new lesson. It is a little bit lengthy, but I wanted to include lots of examples so that you can go back and look at it if you're struggling with the assignment. Okay, so looking at this, we'll start off with the first statement here that y is a function of x. And that is because y depends on x. Okay, now we talked about this before, that the x-axis goes left and right, and this is the independent variable. And the y goes up and down. This is the dependent variable. So y depends on x, so y is a function of x. So let's look at this in terms of an example of an equation. So we have an equation here where y is equal to 3x. Well, you wouldn't be able to figure out what y is until you were given an x, right? So you would be given an x, you put the x into the equation, and then you can calculate the y. So if, on the other hand, you were told that x is 2, then y would equal, right, 3 times 2, which means that y would equal 6. Simply putting the 2 into that equation, okay? Now, you can replace that y with the symbol f of x. And we talk about that, right? F with a bracket with x in it. When we talk about it or speak of it, it means f of x, or we can say f at x. Okay? So f is the name of the function. We can use different, we often use f because it is the first letter of the word function, but it can be a g of x or h of x. We can use a number of different letters. So f is the name of the function and x is the variable used in the function. So this is called function notation, okay? So function notation is when we're talking about something like f of x. Okay, so when you see f of x, it means the same as the y value. We're just taking the y and we're replacing it with the f of x. Because really, y depends on what the value of the x is. Okay? It does not mean f multiplies. Okay? It does not mean f multiplies x. Okay? The bracket there does not mean multiply. Okay? So be clear about that. So let's go through some first examples. Here's a function, right? It's an equation we've seen before. So y is equal to 2x minus 1. We can change this into function notation by simply taking out the y and putting in the f of x. So the function notation would be expressed with f of x instead of the y is equal to 2x minus 1. That's function notation. Okay? So we're just going to do a few examples here where we're going to take and we're going to write these basic equations in function notation. So you're simply taking out the x, taking out the y, putting in f of x is equal to 4x plus 1. Very simple, right? Second example, take out the y, f of x is replacing the y is equal to x squared minus 5x plus 1. Taking out the y, replacing it with f of x is going to equal 2 to the x. We've just written this in function notation. Not too difficult to do, okay? Now, if we're thinking about working with function notation, if f of x is equal to 3x plus 1, then this is the same as y is equal to 3x plus 1. So instead of saying x is equal to 2, we can write the function notation f of 2. Okay? That can also be said when the function notation is f at 2. What that means is we're going to replace the x, right? The x was here with the number 2. And then we simply calculate the value of the y. Okay? So let's look at a very simple example. Here's our original function notation. We're told now the f of x is going to be f at 2. So we're going to take the x and we're going to replace it with a 2. And then we're simply going to calculate. When you calculate, you follow BEDMAS. So we're going to multiply first. 3 times 2 is 6, and then 6 plus 1 is 7. So this means when x was 2, y is going to equal 7. Okay? So as I was saying before, we can have function notation for more than one function. So this one is an f of x is 4x plus 1, and this one is g of x is equal to 7 minus x. So now we want to find the values of the coordinate points. So we're going to be looking for x and y and create a point that could then be graphed. Okay, so we're simply going to take the function that we have and substitute it with the given x value. So this is f of x. So it's going to be f at 7 is going to equal, right, using this function up here, 4. Take the x out and replace it with a 7. And then plus 1. We're simply going to calculate, multiply first. So 7 times 4 is 28. 28 plus 1 equals 29. So now, when x is 7, y is going to be 29. So this is our x value, and the second one is our y value. So 7 and 29 are going to be the ordered pair for the function g of x. Okay? The next function, we're going to use this g of x is equal to 7 minus x. So we're simply going to substitute. So g at -2, we're going to take that function, we're going to substitute instead of the x, we're going to put in our -2 using a bracket. So now we're going to have 7 minus -2. Remember, when we have two signs like this, we can simplify it, add the opposite, and now this is going to equal +9. So this is our x value, and this is now our y value. Okay, so when g is at -2, it means our y is going to equal 9. So putting it into our ordered pair, the x is -2, the y is 9. Okay, let's try another one. We're going back to the f of x. We're going to go f at -3. So if f is at -3, whoops, erase that. So if f is at -3, we're going to substitute in, and we're going to have 4 bracket -3 plus 1. Calculate it. 4 times -3 is -12. Then -12 plus 1 is -11. So f at -3 equals -11. That means the ordered pair, the x is -3 and the y is -11. All right. Let's look at the last example of this type. So we're looking at the g of x, where the x is 7. So for g of x at 7, it's going to be substituted in. And we have what's going on with my pen? 7 minus, and then in brackets 7, and then 7 minus 7 is equal to 0. So when g of x is at 7, the y is 0. So our ordered pair, x value is 7 and y value is 0. We can plot those points. Okay, now let's look at using function notation in another example here. A little bit more complicated formulas. So again, our f of x and our g of x. So our f of x is going to be at 2. We're going to substitute into this equation for our f. So if f is at 2, we're going to substitute our x's with 2. So we would have 2 in a bracket, which is squared, plus 3 bracket 2 minus 5. Remember, you're calculating following BEDMAS, so that means exponents are going to go first here. So 2 squared is 4. Then we're going to do our multiply, which is plus 6. And now we're going to add and subtract from left to right. So 4 plus 6 is 10, and then 10 minus 5 gives us 5. So when x is 2, y is 5. That's our ordered pair. Okay, let's look at g of x. A little bit more complicated with a square root symbol. So substitute in. So when g is at 22, it means we're going to substitute the x with the 22. So then we're going to look at the square root of, and then 22 plus 3 is going to be in the radical sign. Simplify in the radical sign, so 22 plus 3 gives us 25. We're taking the square root of 25, and that equals 5. So when x is at 22, y is at 5. Okay. Do a couple more of these. So f of x is at -3. It means we're going to substitute -3 in where the x is. So -3 squared plus 3 bracket -3 minus 5. Just simply use a bracket to substitute. Now we have to be careful here. -3 squared actually means -3 times -3. So negative times a negative is going to give us +9. Okay? And then +3 times -3 is going to give us -9 and then -5. So +9 minus -9 gives us 0, and 0 minus 5 equals -5. So when x is -3, y is going to equal -5. The last example of these is when g of x is at -2. So simply g at -2 means we're going to substitute the x in with a -2. So we've got our radical sign, right? We're looking at this g of x up here. So the radical sign is going to have -2 in it, plus 3. Simplify in the radical first. So -2 plus 3 is 1. The square root of 1 equals 1. So when x is -2, y equals 1. Okay, now moving on, we're going to look at that f at 3 is equal to 5. So what do we know from this? If f is at 3, that means the x value is 3. And if f of x at 3 is equal to 5, we know that the y value is in fact 5. Okay? This is the x and this is the y. So now we can actually plot this point. So remember that the x value goes first, the second value goes second. Or sorry, the y value goes second. And x is left and right and y is up and down. So in this particular case, if the x value is 3, we're going to go to the right 3. And the y value is 5, we're going to go up or down, and it's positive, so we're going to go up 5. Okay, so we can plot those points. So now we're going to just go back and do a little bit of a refresher on graphing. Okay, so f at 3 is equal to 5 means the x is 3 and the y is 5. Now we want to plot that point. So remember, we started our 0 intersection here, which we call the origin. And we're going to go to the right 1, 2, 3, and then we're going to go up 1, 2, 3, 4, 5, and we're going to plot that point, and we're going to have to label it because you're going to do more than one point, and I need to make sure you have the right point in the right location. So you have to tell me this is point A. For the second example here, it's f at negative 2, that's our x value is equal to 3, which is our y. So this is going to be negative 2, 3. So starting at the origin, we're going to go left or right first. So in this case, we're going left 2, and then we're going to go up 1, 2, 3, plot our point, and that is point B. For the third example, our x is 0 and our y is negative 2. So nowhere left and right, and then we're going to go down 1, 2, plot our point, that is point C. Okay, so labeling the points. Moving on to a second example, we want to be able to interpret or find the missing value from a graph. So we're going to use the grid provided to find the indicated missing value. So we're looking for the y value here. So remember, this is when x is negative 2, what's our y? So we go on our graph, we start at the origin, and we want to move until x is negative 2. When x is negative 2, this is the location that we find on the graph. So that means our y value has gone up 1. So this is f at negative 2 equals 1. Okay? Let's look at the second example. So f at 0, that means our x value is 0, so we're going to be nowhere left and right, and then we go to where the graph meets that x at 0, and that's this location, and it tells us that the y value is going to be 2. All right, our third example, we're looking at f at 3, which means x is going to be 3. So x at 3 means we're going to go to the right, 1, 2, 3. There's our location right there. And it's on the y-axis. We don't have to go up or down, so our y is going to equal a 0 there. Okay? Now, to kind of throw it a little bit differently, we want to figure out what the x is. We know that our y is at negative 3. So remember, y goes up and down, so we're going to go down in this case to 1 to negative 3. And then we're going to go across till we hit our line. And when y is negative 3, our x is negative 1, 2, 3, 4. So this is going to be f at negative 4 equals negative 3. Another example where we have our y value, we're going to go up 1, 2, 3, 4, and we're going to go until we hit our line, which is going to be right there, and that's where our x is then at 2. Okay, so you're just looking at finding the ordered pair at that location when you're given only one of the one of the numbers in the ordered pair. Okay, moving on, we're going to be using, in example 5, we're going to be using again a couple of different functions, and we want to find the value of x. Now this is a little bit more difficult because you have to rearrange the equation to solve for the unknown x. Okay, so simply thinking about this, we're told that our f of x is equal to 1 in this case. So here's f of x. So all we're going to do is we're going to take out the f of x and we're going to put in that value 1. So that means that the equation was 2x minus 5 is now going to equal 1 instead of f of x. Okay? We'll solve that in a minute, but let's try this again. Look at the second one here for g at x. Okay? So we're going to take out the g at x and we're going to replace it with a 25. So now the square root of x plus 15 is not going to equal g of x. It's now going to equal 25. We're just replacing the g of x or the f of x symbol with what it equals. Okay, let's now go and solve these. Okay, the first one's easy. You need to get x all by itself, so you're going to add 5 to both sides. That leaves us with 2x is equal to 1 plus 5 is 6. Getting rid of the 2's multiplying the x, so you're going to divide by 2 on both sides, and x is equal to 3. Okay, so we have just solved this. So we could, in fact, put this back into the function, and we can go f at 3 is equal to 1. Okay. Second one's a little bit different because we got a radical sign in there, but still, let's work at it where we're trying to get x all by itself. So get rid of the add 15, so we're going to subtract 15 from both sides. Okay, so that gives us the square root of x is equal to 25 minus 15, which equals 10. Now, we have to think about this a little bit differently. What number, if we took the square root of it, would equal 10? Okay, so the square root of what number equals 10? Well, that number would have to be 100. X would have to equal 100 because the square root of 100 equals 10. Okay, so again, we can rewrite this now to say, put our answer of x being 100 back into the function notation. So g at 100 is equal to 25. Okay, let's do this again. F of x is equal to -1. So we're going to take the f of x symbol out and we're going to put in -1. So this is going to be 2x minus 5 is equal to -1. Getting x all by itself, you add 5 to both sides. And now what we have left is 2x is equal to -1 plus 5 is 4. Then we divide both sides by 2, and x is equal to 2. Okay, we can put it back into this function notation. So now saying f at 2 is going to equal -1. Okay, the last one of these, we're going to take and replace the y or the g of x with 22. So we're going to go back and look at the original. So we're taking out the g of x and we're going to put in a 22. So now we're going to have the square root of x plus 15. Instead of equaling the g of x, it's going to equal the 22 we have here. All right, so let's get the x all by itself. So the first step is to get rid of the 15. So we're going to minus 15 from both sides. So now we have the square root of x is equal to, and 22 minus 15 is 7. So now thinking, what number, if we take the square root of it, is going to equal 7? Right? So that number is going to have to be 49 because the square root of 49 equals 7. That means that x is going to equal 49. Okay? Again, if we want to put it back into this function notation, when g is at 49, it's going to equal 22. Okay. Now, you're going to have some word problems, okay? And so I want to go through a word problem here, and the word problems have formulas, which really are just function notation. So we're looking at the height of an object above the ground when it is thrown in the air, right? And we have an equation where t, the small t in the equation, is the time in seconds, and h, the function of t, is the height in meters. So this equation will tell us, right, how high an object is above the ground in a specific amount of time when it's thrown in the air. Okay, so we're going to start with h at 0 and figure out what that equals. Okay, remember h at 0 means that this is in fact the t. Okay, so we're going to substitute when h is at 0. We're going to have 20, take the t out and substitute the value 0 in. Subtract 5, take the t out here and substitute a 0 squared. So now calculate it. Remember, we have to do exponents first, so 0 squared is 0. And now we have 20 times 0, which is 0, minus 5 times 0, which is 0, and 0 minus 0 is 0. So this should make sense, right? At time 0, the height should be 0, right? So at time 0, the height should be at 0. Well, what happens now if our time is at 2 seconds, right? What's our height going to be? So h at 2. What's our height at 2 seconds, basically? Okay. So h at 2, substitute into this formula. So we're going to have 20 bracket 2, subtract 5 bracket 2 squared. Now again, following BEDMAS to calculate this, we need to do our exponents first. So 2 squared gives us 4. So now we're going to have 20 times 2 subtract 5 times 4. We simply multiply from left to right. So 20 times 2 is 40. Subtract 4 times 5, which is 20. And 40 minus 20 gives us 20. So basically what this is saying is that at 2 seconds, right, because it's h of t, it's going to equal 20. So the height is going to be then 20 meters. Okay? Let's do this again. If h at 4 is equal to 0, we want to complete this sentence. What's happening? So remember, this is h of t. This is time. So at 4 seconds. And h of t, which is the height at 4 seconds, what is the height? Right? The height is equal to 0. So what's happened there? How can the height be at 0 after 4 seconds? Well, think, you're throwing the ball in the air. What happens when you throw the ball in the air? Eventually it comes back down. So that means if the time is 4 seconds, the height above the ground is 0 meters. How can this be? This means that the object has what? Hit the ground, right? It has gone up and come back and hit the ground. All right, good luck, folks. And there is what appears to be lots to do on the assignment, but you should be able to manage to get through it with all my examples. All right, take care.